And we're continuing our work with solving quadratic equations in quadratic form. This time we have two equations that have three terms each. And the reason they're not quadratic equations is because the degree is 2/3 instead of squared, right? Quadratic equation degree is 2. So we're going to first rewrite this equation with a 0 on one side. So x to the 2/3 minus 6x to the 1/3 plus 8 equals 0. Let's get this looking, the 0 on one side. And now, remember, we are trying to do a U-substitution that will let us rewrite this original equation so that it looks like this, right? Which means that our new variable u is going to represent the x to the 1/3. And just a reminder that a rational exponent of 1/3 means cube root. So this is another representation of just the cube root of x, right? So u equals the cube root of x. And then we're going to square u. So square the 1/3, the x to the 1/3, which means that by power rule we multiply these two exponents and multiply across those fractions. So this is x to the 2/3, which is a good thing because that means that we can take u squared and substitute it for that x to the 2/3 that's there. So we have u squared minus 6u plus 8 equals 0. And I've got a quadratic equation that factors, so I'm going to go ahead and solve for u here. And by factoring, and then I'm going to take each of these factors that are here, and I'm going to set them equal to 0 so that I can solve for u. So u equals 2 or u equals 4. But I can't stop here because what I really want to solve for is x. So I'm going to go back up here and remind myself that u was representing that cube root of x, right? That x to the 1/3. Okay. So I'm going to replace that back in for the u. And how do we solve these cube root problems? Well, we do the opposite operation. So the opposite of taking a cube root is to cube both sides. So we're going to go ahead and cube both sides of this equation so that we can solve for x. And so here we get x. The cube root of x cubed is just x. And then here we get 8. And then here we get x. And then here we get 64. So my two answers are 8 and 64. All right, number 6 is similar, isn't it? So once again, we're going to get this into standard form. We're going to subtract the 8x to the 1/3 and the 15 equals 0. We're going to use the same substitution. We're going to say u is x to the 1/3. And u squared, as we showed in the last problem, is x to the 2/3. So this is going to be 12u squared minus 8u minus 15 equals 0. So now, these are big numbers for factoring. So if we don't want to hassle with factoring big numbers, we can always use the quadratic formula, which is also big numbers, but we can do all that in our calculator, right? So let's go ahead and do that. Let's just practice solving for u using the quadratic formula. So a is 12, b is -8, c is -15. So u equals the opposite of b, so that's 8, plus or minus the square root of b squared. B squared is -8 squared, which is 64, minus 4, 8 times c, 180, right? 4 times 180. Negative, right? Negative 180. All over 2 times a, which is 24. Okay, so this radicand is kind of big. But what do we have to have here? So here, this 64 minus 4 times negative 180. This radicand gives us 784. So we have 8 plus or minus the square root of 784 over 24. And then this is a perfect square, which is 28. So u equals 8 plus 28 over 24. So what do we get there? 36 over 24, which is 12 goes into both of those, so 3/2. Or u equals 8 minus 28 over 24, which is a negative 20 over 24, which is a negative 5/6 when you reduce. Okay, but that's u, so don't stop there, right? So let's go back and put in our cube root of x, right? U is the cube root of x, so x to the 1/3 or cube root of x is 3/2, or x to the 1/3 cube root of x is negative 5/6. And so now we're going to cube both sides to just get the x. Okay. So x equals, and how do you cube this? Well, you cube the numerator and the denominator. So 3 cubed is 27, 2 cubed is 8. So 27/8, or x is negative 5 cubed is negative 125, and then 6 cubed is 216. So our two answers, 27/8, I know that looks ugly, and negative 125, 216, which you can check using your calculator.